Hi everyone, this is the second video on finding the nth term of a quadratic sequence. In this video we are going to tackle some of the harder quadratic sequences. Right, we've got a sequence on there. The first thing we need to do is to determine whether it is a quadratic sequence, and we always need to start off from this step. So what we will do is find our first difference. And the first difference is the difference between consecutive terms. So basically I'm just going to find the difference between 3 and 6. To go from 3 to 6 I need to add 3. From 6 to 13 I need to add 7. From 13 to 24 I add 11. From 24 to 39 I will add 15. The next thing I need to do is find out the second differences. So that's D2. And that's the differences of the differences. So to go from 3 to 7, I add 4. From 7 to 11, add 4 again. 11 to 15, add 4 again. And as I can clearly see, my second differences are the same. The next thing I need to do is, this is the most important step I think in this whole process. If we miss this out, we'll end up not being able to find the nth term correctly. So I need to divide my second difference by 2. This is 4 divided by 2, which is 2. And a double underline and put a bubble around this, or cloud, whichever you prefer. And here we go. Again, just a quick reminder, to ensure we have a quadratic sequence, the second difference needs to be the same every single time. Okay, once we've done all of that, I'm going to rewrite my original sequence over here. So I'm going to start off with 3, 6, 13, 24, and 39. And now I shall number these sequences. So n stands for term number, as we know from the previous videos. So 3 is my first term, 6 is my second term, 13 is my third term, with the commas, 24 is the fourth term, and 39 is the fifth term. And because we're dealing with quadratic sequences, I'm going to square my n's. So 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. Alright. Now once I've done that, I am now going to go to my bubble. And the number which I've underlined over here is 2. So I need to multiply my n squared by 2. So that'll give me 2n squared. So to get the first number, 2 times 1 is 2. 2 times 4, 8. 2 times 9, 18. 2 times 16, 32. And 2 times 25 is 50. Alright. That's nice and easy so far. Okay, next step is I need to go from this 2 all the way to my original 3. And in order to do that, I need to add 1. From 8 all the way to the 6, I need to subtract 2. And 18 to the 13, this time I need to subtract 5. And 32 to 24, I need to subtract 8. and 50 to 39. I need to subtract 11. Okay. Now, I can see these are not the same number each time like the previous video. So what I need to do is find the nth term of these numbers here, this sequence. And if you notice, if I was to go from 1 to minus 2, right? If I was to go from 1 to minus 2, I have to subtract 3. And minus 2 to minus 5, I have to subtract again 3. Minus 5 to minus 8, I have to subtract 3, and subtract 3 again from minus 8 to 11. So because I'm subtracting each time by 3, I can find this is an arithmetic sequence because it decreases by 3 each time. So I can find out the nth term of this. So what we are going to do, I'm just going to quickly get rid of these minus 3's and replace it with the minus 3 times table. Here we go, and we will write down the minus 3 times table. So that's minus 3 times 1 will give me minus 3, minus 3 times 2 will give me minus 6, minus 3 times 3 will give me minus 9, minus 3 times 4 will give me minus 12, minus 3 times 5 will give me minus 15. And the nth term for the minus 3 times table is minus 3n. Okay, so the last bit which I need to do is to see how can I go from minus 3 to 1 and minus 6 to minus 2. I have to add 4 here, add 4, minus 9 to minus 5, add 4, and minus 12 to minus 8, add 4, and minus 15 to minus 11, add 4. So the nth term of this purple sequence over here is going to be minus 3n, add 4. Brilliant. So now what I'm left with is if I add up this sequence over here, the 2n squared, and I add it to minus 3n plus 4, I should get the original sequence. So 2 plus 1 is 3. 8 minus 2, or 8 plus minus 2, which will give me 8 minus 2, will give me 6. 18 plus minus 5 will give me 13. 32 plus minus 8 will give me 24. 50 plus minus 11 is 39. So what I can conclude from this is the nth term of this sequence over here will be 2n squared, that's the red one over here, and then I add this one, so that'll be minus 3n plus 4. And that's how we find the nth term of a slightly complicated quadratic sequence. Hope you had fun with this. All the best. Bye.